Hi there, I'm Professor Henrik Hautrup Lund of our Center for Playware here at the Technical University of Denmark. And I'm going to be your lecturer here on the Playware course. The Playware course will have this year in a little bit different format because part of it has to be in virtual form due to the coronavirus pandemic that we have all around the world. So also here we'll have to have some components that are virtual, like my lectures for you that I'll be giving here in this kind of format. But maybe that also has some advantage, namely that you can fast forward and rewind in the lectures, and we'll still in the course have a lot of hands-on experiments for you so that you can get into programming artifacts, technological artifacts to create play and playful experiences. So you get your hands on to actually create some of the things that I will be talking about in the lectures that you'll be hearing here in this format. And it's going to be quite fun because play and playware is a fun theme. It's about creating enjoyment and happiness for people using your technology that you're going to create. So we're going to have a lot of fun in the course, also despite that part of it has to be like this in the virtual form. And play is in general important here, and we are creating playware as intelligent hardware and software that creates playful experiences for all kind of people in the course. And the course will be partly with lectures, partly papers that you're reading, partly hands-on experiments and projects creating your own playful technology. So in the Playware Technology course here, we are from the Center for Playware, where we're doing this kind of technology and research into playware. And the plan is that we'll have this in two parts, the course in two parts. The first part will be with lectures every time. There'll be a number of exercises that you'll go through where you're getting to get to program both some external hardware pieces and some smart devices. And there'll be at the end of that, there'll be a small mini project called that you can, where you make your own small game. And then in the second half of the course, we'll work on the project. So you'll come in a group with a project proposal, and we'll do the project work, and then you'll hand in your project and your report in early May. Now, Playware Technology is a lot of different things. It is there is a lot of theory as well. So we have a number of articles. So you are supposed to read these articles. They are numbered by 1 to 7. So for each of the first 7 weeks, you should read for the first week those numbered 1, second week those numbered 2, and so forth, and then present and discuss this with each other in the small group that you are assigned to, so that you can get a feeling for these subjects that we have in the articles, and the articles are supported by what I'm going to present in the lectures as well. But for each week, read these 2 or 3 articles and use time in your group to discuss this with each other. And then also, as I mentioned, we put a lot of emphasis on hands-on. This is really, you want to go in and make some of these fun things. So you should be able to, after this course, to actually create your own external devices that are interactive and playful. So you'll have a number of exercises and the project, and that's really the core of the course. Even if we are having the lectures, even if we are reading the articles, it's really when you get into creating things yourself that we should put a lot of our emphasis. We do unfortunately only have a limited set number of equipments for you, so you have to do this in group work. So your group will have some equipment assigned to you, and you should take care of this equipment. That's your responsibility. It's some costly equipment, so you should be sure that you don't ruin this, and that you have it up working. You're responsible yourself for charging batteries and so forth. And then of course have fun. This is supposed to be some of the things that we learn from this is that if you're having fun, then you're probably motivated, and the motivation is important. That's when we get into wanting to do different things. So as I mentioned, we'll have an intermediate mini project where you make your individual game. Each of you make a game. We have the final project, which will be in groups. So you work together with your group, creating that project and handing in the project. But the report for that has to be individual. So we are demanded to have an individual report from each of you, but your group hands in the game, the product that you're making. The videos on that is shared between you, but the written report, we just have to have one from each of you. Now, you may know that DTU has a strategy for the next 4 or 5 years, which is technology for people. So DTU wants to work to create sustainable value and welfare in society. And actually, the Playware is exactly about this. This course is about how do we create technology for people. So how can you be sure that the technology that you are learning in many different of your courses can actually be used for people, applied in society, be user-friendly, be so that it will be adopted by people in society. So we want to give you some knowledge on what is the process to take a lot of the knowledge that you have and bring that into society, bring that into the hands of real people. So also when you make your project, if you can go out and test this with real people, that's a huge advantage in this course. So the lecture themes will be things surrounding some of these areas that I put up here, like what is Playware. We'll look into things like the modular interactive tiles, modern artificial intelligence, and how that's being applied in game artificial intelligence. We'll look into distributed processing, how many units can work together, how that can be an advantage of having not a centralized system, but a system with many units. From this, we can create what is called the behavior-based systems. We'll look into also if we have many modules, this can become a user configurable modular system where you can put modules together. We'll look about how do you create interactivity, how can we create tangible, physical, interactive technology, adaptivity. How can you make your system adapt to the individual user? Will be some of the themes that we'll be looking at. And then, of course, we have the practical themes, which are important. Make a Playware. You get to make your own Playware technology. You'll look into what does it mean to create a modular system? How can you have modules to communicate with each other? How can you distribute the processing? So one module does one thing, another module, another thing, and what is the advantage of that? How do you create an embedded system? So you'll get knowledge on embedded system programming. So it's one device that has its own processor that you can program. And we'll get knowledge about radio communication. How do you communicate, for instance, between this physical entity and a smart device where you may be running Android? So we'll be looking at that from a tablet or smartphone programming. How do you program an app that can control this physical device? and look at the user interface, maybe even a server up on the internet. So imagine that you're with your app, you're controlling a physical device, but from the app you can also have things going up on a server on the internet. So remotely you can control that physical device. And then we'll look a lot into user testing. How can you have real users to use your device and learn from that, the qualitative and quantitative learning that you can have from that. So essentially, so put on at the bottom here, you learn how to make small hardware devices that can be controlled from an app and possibly from the internet. So this could, for instance, be for mHealth, mobile health, that you have smart devices talking to external devices controlled from the internet. You can think of it even as things like smart watches. Fitbit is another good example. Some external devices that you're controlling, small hardware devices that is controlled from an app and possibly from the internet. So when we are talking about implementation on some specific playware, please keep in mind this can be abstracted to give you the knowledge to create things like the smart watches and Fitbits and whatever other idea you may have in the future. But let's make it fun and playful, not only something that processes, but something that you'll have fun with. Now, playware we define as intelligent hardware and software that creates play and playful experiences for users of all ages. And often we say that when we create such playware, we would like it to meet what we term the playware ABC concept, where we would like to create technology for anybody, anywhere, anytime, so that our technology can be created for anybody, anywhere, anytime. And we do that by the B, building bodies and brains. Here you should think of the building bodies and brains as building hardware. The body is the hardware and brains the software. Or even in terms of artificial intelligence, there's a lot of focus on embodied artificial intelligence, which is looking at the interplay between the brain and the physical body. So we're building hardware and software, body and brain, and that should facilitate the C, that we can construct, combine, and create. So we allow the user with our technology that they can use anywhere, anytime, to construct, combine, and create. And this could be a good example to bring this to anybody, anywhere, anytime. Things like here, the modular tiles used for playful rehabilitation of children with cerebral palsy or who are crippled in the middle of, here is in Tanzania, in the rural area of deep inside Tanzania in Africa. Where, as you can see, the environment is quite different, but nevertheless, we can develop a technology that can be used by anybody, anywhere, anytime, like this. And as you can see here on the video, a modular approach, as talk about this, they can take the modules like this, bring those in their hands, put them up anywhere that they like. For instance, in the small house we see there, put this out on the ground and start playing games. Here, one is red, one is blue, and one is green. The one who first catches 10 wins the game. And you see, they're having fun. They're laughing, they're enjoying themselves, they are getting physical active. And they understand playing these games within seconds. They start playing together in social play, as you can see. So they're having fun, while at the same time maybe learning things, maybe doing rehabilitation, whatever the purpose may be of the playware. So in this case, it's important that we said we can bring this out to anybody, anywhere, anytime, in order to create impact. So it's not just about us creating this as student in the lab here at the DTU, but how can we make sure that we create it so well that it is so easy to understand that anybody can use this, and that we can make a network like we show here, a collaboration between ministries, hospitals, in this case, go out to the regional hospitals, rehab centers, the community rehab. So really reach out there where it has a real concrete impact on people's lives. And that's where we would like you to think about where you go with the work that you're doing here, that you can actually make a difference with this as an engineering student, and use that to go on and do something good afterwards. You can take the same thing and use, for instance, for football training, as we do with the FC Copenhagen team here for the football training, for the best talents, the talent team, to not for rehabilitation as we saw in Africa, but here for motoric skill training. So you can imagine that this technology, the same as we saw from Africa, you can put up here, and the coach says to the small football players here, you have to run around the cone every time you hit one of these. You have to run around the cone and find this to your color, and the one who first catches 10 wins the game again. Or he can choose to set it up in a different manner, like here. Just creating differently. You remember the C, construct, combine, and create. So here the coach has created in not a physical setup. Or we can create other kind of modular playware. For instance, for music, as we do here with the big music star Peter Gabriel. He was very big in the 80s and the 90s, had a hit called Sledgehammer and others. He even today play for big crowds like this, 15,000 people every night. So we create with the playware, some modular playware that he can use for his stage performance. In this case, you can see the cubes here, 5 different cubes for each instrument. So one is for vocal, one is for guitar, one is for the drums, one for bass, and one for the keyboards. And when you turn the cube, you get different expression of that instrument depending on how you turn this. So as you can see here from the latest European tour, then they can use the modular playware for remixing music as stage performance in front of these 15,000 people every evening. You can hear the guitar there when he changes that. So every time he turns, he gets a different expression of the guitar. And now comes the keyboard player. You can hear when he turns that you get the keyboard. And now comes the vocal. It's Peter Gabriel himself. So as you can see, playware can be many things. It can also be wearable, like in this case with Marceli, who has a wearable on him, and whenever he moves, he's controlling the animation that you see on the stage here. So the big animation when he moves, he's controlling that one to make an art performance. Or you can think of something different, like games. You can bring those games out in a physical form, like the next one here. This is from MIT Media Lab. You can see each of this. This is a big skyscraper, and each of these lights is from where they're controlling the light of a room, an office room, and they're standing outside the big skyscraper here and controlling with a smart device the Tetris from each room in that big building. They control delight, and they can make that into a physical game. So you're actually playing with the whole building here. The whole building becomes a physical play device for you. So it's quite fun to think about what can be made into with technology, what can be made into something playful and fun for you to interact with. So in general, we say that this Playware is technology, intelligent hardware and software for play. And we can take inspiration from robotic technology to create it, because robotic technology is characterized by its allows us to create many different interactions in the physical environment. So that's something we do with Playware. That's the kind of things we would like to. And then the extra thing with Playware is that we can motivate people to interact with this technology because of the immediate feedback it can create, because of the playful interaction. And play is interesting here because play is a free and voluntary activity that we do for no other purpose than play itself. We play for the sheer enjoyment that it brings to us. So we can say that play is a game where we are discovering the rules while we are playing, and it's always changing, and it always brings us something new. And interestingly, this has been studied obviously for hundreds of years. What is play? And for instance, Vygotsky from development psychology looked at this in the 1930s, and said that play creates a zone of proximal development in the child, and in play the child behaves beyond his average age, beyond his daily behavior. And in play, it's though as he is a head taller than himself, he can suddenly do more. And that's interesting. If that's the case in play, then we can suddenly do more than we would normally do because we forget about time and place when we are in a play zone. Then we may think this can also be used for other people than children, for adult in health, for instance. Um, and if we look at this zone of proximal development that's being mentioned here, that's quite interesting as well. And just enlarge that this picture here. So we know that if we give people a challenge, we have the level of challenge up on the y-axis and level of competences on the x-axis. Now imagine you have somebody who has a small, not a high level of competency, but you give that person a high level of challenge, then you will become anxious, most probably, because you cannot solve that task that you're given. Whereas on the other hand, if you have a very high level of competency and we give you just a low level challenge, then you'll soon feel bored. So the whole trick here is, can we give you the right level of challenge to your competence? Can we make you fit into the challenge, fit into this, what is called the zone of proximal development? So you can kind of climb the ladder up in this zone of proximal development, where you get a challenge that is maybe 5% above your normal level of competency. Then you can solve that and little by little climb up this ladder. So if we can do that, that's quite interesting. And imagine we can put that into our technology so that the technology adapts to fit to your particular level of competency and give you that right level of challenge all the time. So that's interesting if we can do that. And play in general is as I say, interesting because play is something that we do. If we take the short form here, we can say that define that play is actions that we undertake to create experiences and delight, something that we do for sheer enjoyment, something that's good for us in our daily life. And we can say that play, how does play arise? Well, we know something that can help us to get into a playful mood. Namely, if I tell you a joke, then suddenly you would relax and you will have more free spirit and not think so much about things. You will start laughing, and probably that will be able to push you into a dynamics where you're in a playful state of being. You also know it from emotion or competition. Say if you go on a swing, if you get it into your stomach, you can feel it in your stomach. That you can think of as a play force that pushes you into a play dynamics. So we can say that the play force is the influence, and the effect become is a dynamic play condition. And now we can imagine that the interactive behavior of a Playware tool is what provides a play force. If you create your technology well enough, then that's the thing that pushes people into a play dynamic. So if you can do that, you really reach far, and you'll have something of real value to bring people into a mood where they will more easily interact with your technology as well. So in general, we can say that what we're doing is we're creating this technology, these tools, with a behavior that should interact with the user. And in that interaction, that works as a play force that pushes people into a play dynamic and into a state of play. And our methodology for doing that is to study and understand two things. We go from two directions and combine those two directions. On one side, we have things from more from the arts and humanities, social sciences, on understanding play and play forces and human motivation, and combine that with the more technical themes of modern AI, modular robotics, tangible interfaces, adaptivity, and so forth. And we bring those two things together to synthesize, to bring some design principles to us to better create Playware, and also to better create, in general, human-robot interaction. And of course, here in this course, we focus on one part of this, the more technical part, but we'll take still in some of the inspiration from the other side as well, to understand better how to create these design principles. So now I've been speaking a long time, so please now take a break from listening to all this and seeing this videos, and then a little bit later you can go and see part of this video again, or you can jump to one of the next lectures on the Playware. So thank you for now.
Mr. David Rhodes, the guitar box. He's still searching. And on the keyboards, Mr. David Sanchez. Now it's time for the ladies' games with Jenny Abrahamson and Vinny Olson.